Hi, this is Jeff Spencer, Math 135 instructor for the Community College of Denver, and this is a video going over the steps to do the p-value method to complete a hypothesis test. So the last few videos were over the critical value method, and now we're going to use the p-value method, which is just a different method to come to the exact same conclusion for a hypothesis test. So keep in mind, if we're rejecting the null under the critical value method, then we're going to be rejecting the null under the p-value method. And if we're not going to reject the null under the p-value method, under the critical value method, then we will fail to reject the null under the p-value method as well. This picture right here shows you kind of why these two approaches come to the same conclusion. We learned from the critical value method that if the test statistic z data is beyond the critical value, this is an example showing the right tail test, then we reject the null. When the test statistic z data is beyond the critical value, we reject the null. The p-value is going to be the probability or the area of getting your test statistic or anything more extreme. In this case, more extreme means into the right tail. The mirror image would be true on the left side. So anytime the z data is beyond the z crit, the probability area, the p-value of getting that value or that test statistic or anything more extreme will always be smaller than alpha. The reverse would be true whenever the test statistic or z data is not beyond the critical value. Then clearly the p-value, which is the area to the right of that curve in a right tail test, or the area beyond the test statistic, this area is going to be much greater than alpha when the test statistic is not beyond the critical value. So we can always say that whenever the p-value is less than alpha, we will reject the null hypothesis, because whenever the p-value is less than alpha, we'll know that the z data is beyond the critical value, that the evidence is significant. And whenever the p-value is greater than alpha, like in this picture, then we will fail to reject the null because the evidence was not significant. So we need to keep in mind, this seems a little counterintuitive, but it's true, that when the p-value, the probability of getting your test statistic or anything more extreme, is small, that means we have stronger evidence for our alternative hypothesis. So a small p-value means stronger evidence, and a larger p-value means less evidence. So we have the steps in general here, but I also have the document of the p-value steps, which I'll make sure to show you and follow as I go through this problem. So this one, it says, suppose it is reported in 2015 that the average age of all CCD students was 24.3 years old. We think that the average has increased since then. So from those couple sentences, we should be able to write the null and alternative hypothesis. We're definitely writing a null and alternative hypothesis with the mean, mu. So mu is going to be equal to, let's see here, 24.3. And then the alternative is going to, give me a second here. The alternative, since we think that the average has increased since then, we're going to write that the alternative HA, that mu is greater than 24.3. I'm sorry, greater than. All right, that's a right tail test. Okay, step 2, we jump straight into the test statistic formula. So since I'm doing a test on mu, I'm going to be using the t-data formula. So I'm going to copy and paste that over. Okay, and in the problem, we should be able to see that so we sampled 50 people, that's n equal 50. Let me pause this and get the formula ready. So the sample size is 50, so we can put in 50 for n. The average age from the sample is 25.1, so that's the 25.1, the sample mean right there. And the mu is 24.3 from the null hypothesis, and then the sample standard deviation is 1.9. So we got to plug this information into the formula. So when I do a test statistic, just because it's a little bit more complicated than your average t or z score, we make sure to do the top. write it down, do the bottom, write it down. So I got to do 25.1 minus 24.3, that's 0.8. So on the top I have 0.8 divided by, now on the bottom I got to do 1.9 divided by the square root of 50, 1.9 divided by the square root of 50. So I'll go to 4 decimals, 0.2687. Then I divide those two values, so 0.8 divided by 0.8 divided by 0.2687, and I get 2.98 rounded to 2 decimals. 2.98. Okay, so that tells me that my test statistic is, I don't know why it does this formatting. My test statistic, my X bar, is 2.98 standard deviations above the null hypothesis mean. So I have evidence that's almost 3 standard deviations above the null hypothesis mean, which is pretty strong evidence. Now I need to compute the probability of getting that evidence if the null hypothesis was true. That's what we call the p-value, the probability of getting this evidence or anything more if the null hypothesis was true. So since I'm computing t data, I'm going to use the area to the left or the right of a t-score. Since my test is right tail, I'm going to use the area to the right of a t-score. So that means I go here to my calculator, I'm using the t-score area calculator, and I'm using the one on the right because it's a right tail test. So I click in here and I put in my t-score, which was 2.98, and then always the sample size minus 1. Now remember, the sample size in this problem was 50, so I'm doing 49 here, and I get 0.022. So just to show what I did the area, to the right of a t-score because I have a t-data and I'm doing a p-value and I have a right tail test. So then I put in that formula, I did 2.98, and then I put in the degrees of freedom, the sample size minus 1. It gave me a p-value of 0.0022. That's this number here. Zoom in on that a little bit more. Okay, so just to show that again, 2.9849, 0.0022. So that's a pretty strong evidence p-value because the p-value is very small. So I have strong evidence for the alternative hypothesis that the average age is greater than 24.3 years old. So the final step of the p-value approach is the conclusion. If the p-value is less than alpha, we reject the null hypothesis. And whenever we reject the null hypothesis, that means that we have found statistically significant evidence for the alternative. That's the case here because step 4, if we look at the p-value of the alpha, it's 0.01. So my p-value, which is 0.0022, is definitely less than alpha, which is 0.01. So in that case, I reject the null hypothesis. Whenever I reject the null hypothesis, I say there is significant evidence, so I always start with that, evidence, for, and then whatever the alternative hypothesis says, that we think that the average age has increased from 24.3. So significant evidence that the average age has increased from 24.3. And that's it. So we'll do example 2 in the next video.